Hello and welcome to the Omnex webinar, latest updates to IATF 16949 and customer CSRs. The presenter for today's webinar is Chad Keimel, Omnex CTO. Chad Keimel is the Omnex CTO and founder. Omnex is an international consulting and training organization headquartered in Ann Arbor, Michigan. Over the course of Chad's successful career, he has served on the Malcolm Baldrige Board of Examiners and has received numerous quality achievement awards, including the Quality Professional of the Year Award from the American Society for Quality Automotive Division. Chad has helped and teaches auditor training for ISO 9001, 14001, 45001, as well as many integrated management systems courses. Chad is on the writing committee for ISO 9001, 45001, 14001, and others. Chad is currently a certified lead auditor for IATF 16949, 14001, 9001, FSSC 22000, HAACP 45001, AS 9100, and many others. During this webinar, if you have any questions for Chad, please enter them in your questions dialog box and he will get to them at the end of the webinar. Go ahead, Chad, you can take it away.
Miles, thank you very much. Welcome, everyone. You know, this presentation that I'm doing this year is a continuation of IATF 16949 presentations we have made since the inception of IATF 16949. And I don't mean to add to that wonderful introduction Miles gave of me, but just for you to know, many moons ago, I happened to do the first worldwide witness audit for the IATF 16949 when it was called QS 9000. So, you know, and I was an integral part in helping one of the OEMs transition from their, you know, standard before QS 9000 to QS 9000. So one of the things I take great pride is in following, you know, and understanding where every standard, every part, every shell, where did it come from? Did it come from Ford Q101, Targets for Excellence, Chrysler's FCA? Or did it come from something we did in ISO TS 16949? Is it from a CSR, et cetera, et cetera? So, you know, let's take a quick look then at what are the main things we should be concerned about within in this new FAQ and SI. Just wanted to pause here and just mention we are a 34-year-old company headquartered here in Ann Arbor, Michigan. We do all kinds of different management systems training, Lean Six Sigma. Of course, we are really focused on electric vehicles and autonomous vehicles and have about 34 different classes that we introduced in the last 2 years. Couple of things in terms of how Omnex became the way it is. We helped Ford Motor Company with their Ford 2000 rollout in the, you know, in the 1990s. Also, we helped the semiconductor industry with their, you know, supply base in Southeast Asia with the industry group called SAC, or Semiconductor Assembly Council. And now, of course, we are very much working with in the aerospace industry, as of course, you know, we work with global tier ones like Magna or Lear or others in terms of providing global services to them. So a little picture of our where we are located worldwide. And I would be remiss if I didn't mention to you, well, I'll do that in a second. I'll introduce two of our co-presenters who are going to be with me today, and it's a good surprise for all of you. All right. So here are, you know, what we're going to do in this order. I'm going to start with the AIAG VDA FMEA update, and to help me, I'm going to have Mr. Mike Down, who helped write all of the core tools when he was part of the task force as a GM lead. And of course, he's still very, very involved. In fact, he's working right now on a SAE update to the FEMA standard. Then we'll go into the FAQs and the sanctioned interpretations, especially the new ones that we should focus in on. And as you may or may not know, cybersecurity is a key item in there, and I'm going to talk quite a bit about that in the second bullet. So I've invited Mr. Anthony John, who is a VP of Omnex Systems and is our IT expert, who joined me and explain a little bit what it means to do testing in cybersecurity, which is in one of the sanctioned interpretations. We'll finish with the Ford's SCCAF, the designation for special characteristics, communication, and agreement between customer and supplier. And all of you are probably doing this already because it's in the CSRs. But let's take a look at the new requirements. And then we'll do the summary. So first then, the AIGVDA updates. So just to remind you, we have the AIGVDA FMEA, and with the 7-step process, the same 7-step process for both design and process FMEA. And this is the form. And the only point I want to make here is that the AIGVDA is very different from the 4th edition because it connects up the higher level system with the, you have something called the focus element, which is in the middle of these threes. You can see colored 3 things here for structure analysis, function analysis, failure analysis. And you can see here, the focus always is on the element in the middle. You can see that system element. And the higher level element here is your customer's system, and the lower level element is the component from your supplier. That's an assumption the AIGVDA makes in terms of doing this. Keep that in mind as I talk about this later. And to tell you that this is a 7-step process with planning, structure analysis, which is the BOM laid out. And I always like to remind viewers and listeners, the structure analysis is a very important step when you do 26262, when you do ASPICE, and when you do cybersecurity ISO 21434. And the idea of the, we call it systems engineering, in laying out how the product breaks down. But keep in mind, as soon as you talk EVAV, we're also talking about the system having hardware and software. Of course, systems are very complicated in automotive. Systems have subsystems. Sometimes subsystems have sub-subsystems. And you might see software and hardware in multiple levels. And it's not as, trivialized in some of the examples we do for you. And then your function analysis, the idea of functions. And of course, Omnex will say functions and requirements. We standardize to make sure when people do, so when you do an ASPICE or 26262 or cybersecurity, when you do requirements, we always say do functions and requirements, so it's easy to bring in to the FMEA. I'll tell you more about that later. So here then are the announcements from, here is the FCA announcement. They said, look, suppliers are allowed to use it immediately. Just let us know if you are using it. And they talked a little bit about, you can see, sourced beginning 2019. So folks, if you're an FCA supplier, you need to learn AIGVDA fairly quickly because you could be one of those source suppliers. Okay? Mike, feel free to jump in anytime. I know there'll be a lag between, what I better slow down a little bit and make sure people are seeing. I do know sometimes there's a lag, but feel free to jump in anytime you'd like to make a point.
Okay.
Right? So here is then the Ford announcement. Ford, we know Ford will accept the new format. Suppliers can use it. Suppliers will be required to utilize AIAG and VDA formats on a per program basis. And they have mentioned, commodities that have functional safety, which is, mechatronic systems that have ASILs in them. They will be doing AIAG, VDA, FMEAs. And I have to tell you, I have more to talk to all those suppliers in terms of how they should be using this so that they can do what is called the engineering V model when using the AIG VDA. And then we have Honda. Honda will accept the new AIG VDA FMEA format. And in 2022, suppliers will be required to apply AIG VDA PFMEA for new production process, new production lines, new production parts, and then for products coming out in 2027, it'll be mandated. Okay, I just said products. They said by January 2027, you'll be mandated to use AIG VDA FMEA. General Motors says program starting in 2023, and Mike, that might be almost immediate, if I'm not mistaken. Is that right?
Yeah,
Or are you actually saying that maybe some DFMEAs have already been completed for 2023? Is that right?
They should be if we're talking about 3 to 4 years prior to a calendar year for the launch. So you'd want to check with GM to make sure what their requirement is for the FMEA. I would say if you're working on anything that has to do with autonomous vehicles, that you're probably going to get pushed into the new AIG VDA handbook format.
So I'll also just say the reason I asked Mike is Mr. FMEA, was Mr. FMEA in General Motors. In fact, Mike, would I be mistaken in saying you've even done probably a few hundred software FMEAs?
Oh yeah, easily. I worked on the Volt the Volt program and when they first got into the hybrid vehicles, the two-mode hybrid truck. We did probably 30 or 40 just on the truck program.
Excellent. Thank you, Mike. And Mike was, one of our very key trainers and implementers, and especially also the writer of software FMEA and a class. And Mike, you're hard at work in what we call the new core tools for functional safety. Is that right?
Yeah, working on programs, training programs on fault tree analysis, hazard analysis,
HARA,
and then the
MSR, right?
Hardware MSR, and then the hardware DFMEA.
Great, excellent. Thank you, Mike.
You're welcome.
So that is sort of the announcements coming from three of the big three and Honda. And just some comments from Omnex. Folks, we absolutely recommend and encourage you to use the AIG VDA DFMEA. How it links the higher level elements to lower level elements and how you have functions and requirements flow down is absolute requirement for functional safety ASPICE, and cybersecurity. So if you do the 4th edition, you will have to do it outside, using software programs like DOORS or Omnex's flow down requirements, and then you'll have to transfer it back into the FMEA. And so it's very important that you adopt the functions requirements approach in terms of even ASPICE's, what is SIS2? I have Nikhil here. Requirements, is requirements elicitation, or is that the one before? Anyway, yeah, one before. So AIGVDA DFMEA, we have a modified 7-step approach, which I'll share with you in the next few slides. Make sure you use the modified approach so you can get the linkage for the V model. And then, of course, best if you have to work with both of them, both AIGVDA and AIG 4th edition, use software. Use anyone's software. Omnex absolutely has software for the AIG 4th edition and AIGVDA DFMEA so that you can go back and forth. So in Omnex's software, you could do what we have something called, we have a package called Flowdown that does a flowdown of requirements. And we of course document requirements using functions and requirements. And I'll tell you a little bit more in terms of methodology later. If you do that and do 4th edition, you'll get the same impact as AIGVDA DFMEA. But really, you should be able to go back and forth. And lastly, because of the announcements, I think it's about time you started working on AIGVDA FMEA. Start your pilots, start learning, get people, experts inside your company so you can start using it. Now, just so that you don't think I'm out of line, it's really difficult to do AIGVDA FMEA if you don't have software. I'm sorry, you just can't handle system, subsystem, subsystem, hardware, software, those layers if you don't have a software package. And I think you looked at the size of the form. All right, next I just want to tell you a little bit, if you don't know and if you're new to the idea of the engineering V, this is what is required, for example, in cybersecurity 26262 or ASPICE. Of course, I don't want to say, give you all kinds of detail, but this is also where we say, you got to integrate, IATF 16949 APQP requirements with these 4. But keep in mind, to do something like this, it's not easy if you don't do something like this. This is the engineering V. And a reminder for you, during the functional analysis step of the AIGVDA, you need to do functions and requirements. And then these functions and requirements, you'll get design. Of course, you come up with design controls, and test detection methods. You'll have testing, and that transfers into the DVPNR, which is the testing requirements on the right-hand side, okay? So your test plan or the DVPNR is inherently linked to your DFMEA, just like the PFMEA and the control plan are linked. So, for the longest time, I'll just mention this to you. Yours truly, came up with a linkage between process flow, PFEMA, and control plan in the 1980s. That's how we came up with Aqua Pro, our software, in 1988. We already had it linked. I don't quite remember if I had DFMEA linked at that point, but I spent many years. I'll just say this: Greg Gruskow, also part of Omnex, also came up with the linkage, and he worked with Ford's DCP. So I don't want to claim it just for myself. And I spent many 10, 20 years preaching, nobody changed. And then, of course, finally, everybody changed. Like that, folks, there's a link between DFMEA and DVPNR. Mike, do you want to say a few words? I don't hear too many people talking about that linkage between the DFMEA and the test plan or DVPNR.
Yeah, and it's difficult to do manually. It's a lot of work, and going into the functional safety part of this, it's going to be required to be able to show evidence that you are doing that linkage, and so that and the if I'm working with complex circuitry and controls, they'll quickly get into some complex failure mode tracking and linkages. So it's we don't want to say that we're pushing software, but it's the matter of the beast that it needs something that'll keep everything connected. And as we go down into the suppliers, the third tier have to make sure the second and first tier suppliers have linkages to critical functional characteristics, so that all becomes a very difficult thing to do manually.
So we have this requirements flow down, and this is why the AIG VDA is very important. And then you actually have a testing flow up. Let me just go. I'm afraid to go page down, and my arrows don't come. But you got to start at the lowest level of testing, and then you go build up. Okay, so testing flow, requirements flow down and testing flow up. Okay, all right, so I didn't have the arrows. This is the modified 7-step approach. You can see here the boundary block diagram. We say it's mandated. And of course, you do the structure analysis and the interface diagram, okay, which is in also that you do, in the step 2. Then in function analysis, we say absolutely functions and requirements is left optional in the handbook. We say functions and requirements, and you'll see later we say functions, requirements. Well, it's there. Let me wait. Then a very big, momentous key thought, because the AIG VDA FMEA borrowed from the VDA FMEA, and they always say the cause of the failure is at the right-hand side, which is at the lower level. So all causes go to, your supplier. Customer does the, DFMEA, it's the supplier's fault. When the supplier does a DFMEA, it's their supplier's fault. So causes flow down. So one of the things the US methodology is always focused on is at the focus level. What can we impact? We can impact our design the most. So Omnex wants to caution and say, first work on the focus level, which is our product, before we look at causes at the lower level. Look at both. Then, after you do risk analysis, link special characteristics to the functions and requirements. Mike, when you present, I'm going to have Mike present the Ford SCAF. We'll find out Ford requires this linkage in the DFMEA. We'll talk to you about what that linkage means. As all of you are IATF 16949 experts, listening to this, you also know it's a requirement in 8.5. What is a subclass, Nikhil? Do you know? All right, I know it's in 8.5.2 or 3, okay? Where you have the control plan, and in that it says that the design FMEA needs to be linked to the PFMEA, but nobody says how. I'll talk more about that when we get to the SCAF. Then, of course, you have optimization, results documentation, and you see that the 7B that we added in, which is a link to the DVPNR, which is very important. So we recommend you use the Omnex 7-step approach. This model can be followed, adopted. We just say, you know, in my old age, I'd like to get a little credit to use what we develop. Just cite us if you're going to use us in, you know, in papers and things like that, or presentations. All right, how about PFMEA? PFMEA, we believe the U.S. does the best in PFMEAs. And we have gotten, you know, very close to, you know, zero defects in our manufacturing plants. So when using AIG VDA PFMEA, we recommend process flow versus structure analysis. It's allowed. It says optional. PFMEA and the control plan approach. Of course, we stress very much at Omnex the shop floor standardization. You shouldn't stop with the control plan. The key is implementing all these controls at the operator level, preventive maintenance, you know, and so on. And all right, so when we did VDA FMEA, many people talked to us about the reverse FMEA. Since Mike Down is our expert and has written this training, let me just have Mike Down talk a little bit about the AIG VDA reverse FMEA that you have to do. Go ahead, Mike.
Yeah, because of the concerns that OEMs have now over risk and risk mitigation and control, you'll have some of the OEMs that will require the reverse FMEA. I would recommend it as something that all companies use, and what you're basically doing is taking what you've learned from the PFMEA and then going to the plant once production is started and going through each operation and verifying that the controls that you had identified in your PFMEA have the occurrence level that you set or the risk level that you assigned to it. And so it would actually be taking historical data from previous processes and looking at the operation and seeing if the part could be misassembled or put in backwards, or what type of gauging systems being used. And if you put a red rabbit through or a test part, how well it will catch that part and identify it. And so it's supposed to, once you've done this reverse FMEA, if you learn something about your process, then you then put it back in to the PFMEA and update the PFMEA. So it's a continuous improvement process. So you're supposed to be using it to observe any improvements that need to be made. A reverse FMEA isn't restricted to either the standard method or the AIAG handbook PFMEA, because really all you're doing is evaluating what controls have been identified and how effective they are. So it doesn't matter which PFMEA you have. So you use the PFMEA as a guide and you identify what the risk is and how good the system is for detecting it. So, and we're working on finishing up a 2-day course in doing reverse FMEA, and it'll be off of the AIG VDA, but it'll also reference the classical 4th edition. So,
Thank you, Mike. So, folks, the reverse FMEA, which is something GM requires in the start of a new program in the shop floor. All right, so that was our, what we wanted to talk to you about in terms of the AIG VDA. I'm going to segue now into IATF 16949, but I'm going to pause and see if you want to ask any questions. I'll just mention to you, based on some of the questions you have asked already, we have not gotten any announcements from the truck OEMs I am connected. I will try to reach out and maybe fill you in the next time I do this, probably in a couple of months, okay? And tell you what is their take on AIGVDA. Folks, I'll also mention the linkage between the DFMA and PFMA is an 8.5.1.1 under in control plan, not 8.5.2 or 8.5.3. Okay, 8.5.1.1. All right. Let's now take a look. We'll start with the FAQs, and then we'll go on to the sanction interpretations. All right. This is about total productive maintenance. As you may or may not know, I spent 2 years where I talked about the top failures in IATF 16949. TPM continues to be one of those items suppliers are failing in their surveillance also. So questions on what is the intent? Why are you using the word total productive maintenance? But because that's a connotation to a whole TPM program with its different pillars of implementation. And the answer they gave is the term total productive maintenance used in IATF refers to various similar approaches that focuses on proactive and preventive techniques. And that's the whole idea, and also getting the operators involved in doing TPM. For example, the industry approach for TPM places responsibility for routine maintenance, such as cleaning, lubricating, and inspecting, in the hands of the operator. Folks, there is a Omnex method called process review that I champion inside Omnex that I developed many years ago, where we have shop floor teams by family of products. We take the best operators and have the supervisor lead this team that does process flow, PFEMA, control plan, and shop floor standardization. In that, I just recently visited a plant which was just, really in bad shape. We have then the operators do 5S and also do incorporate TPM into the process, into the control plan, and into the process controls on the shop floor. And this is the way you should also be doing, implementing this. Of course, you don't need to do this to satisfy IATF 16949. So here's what they say. Individual requirements A through J are as stated in IATF 16949. The use of the term gives you the opportunity to adopt the underlying principles of TPM. So we do encourage TPM and TPM adoption. I said that, by the way, that's not in the FAQ. FAQ 28 is about manufacturing process audits, the idea of frequency and coverage. Let me just simplify what they said. What they said is, look, we're not telling you to do every process in a 3-year frequency. 3 years is a minimum, and is intended for very low risk and fully compliant manufacturing processes. You should be doing others with higher risk more frequently. So that is what you have in this FAQ. Moving on, we have contingency plans. In fact, this there's a sanctioned interpretation, because there's a big part of today what I want to talk to you about, which is I think the biggest amount of work we have to do, comes in cybersecurity. So how did this word cyber attack come in? You will see, I think, I forget what month in 2019. In fact, let me look up my notes here. The IATF introduced in 10 October 2017, they introduced that in the contingency plan, you have to do a simulation of a cyber attack, and you need to consider it. Of course, nobody really knew what was meant by that, because cyber attack is not a word, used commonly. So here is the answer. A cyber attack is an attempt to gain illegal access to a computer or computer system, causing damage or harm. A cyber attack is often a deliberate exploitation of weaknesses in the security. Don't think about your PC. This is about the enterprise and network. By the way, I will have Anthony talk to you about 3 different attacks or 3 different assets we have in our company and 3 different types of testing we have to do. These actions may have disruptive consequences that can compromise confidential data and lead to cyber crimes. Cyber attacks and cyber crimes are not always a result of sophisticated series of actions. It could also be email notes where they, how they gain, or phone calls announcing fake emergencies. Anyway, cyber criminals are trying to get into our company systems, and this is indeed a very, very alarming, dangerous, something to the entire supply chain. We're only as good as our weakest in the supply chain. So that's what's the idea of the cyber attack. Let's go in now and learn a little bit more, but you'll have to be a little patient because I'll cover certain other sanction interpretations before I get to the cybersecurity one. So these sanction interpretations that I'm talking about is effective January 2020. Assume you will get audited in your next surveillance audit to these requirements. So it becomes a high priority for you that you take a good look at it. All right. So sanction interpretation 16 is just that in the management review inputs, you got to put something in that's actually in the body of the standard in 8.3.4.1 monitoring, which is under design, design and 8.3. Suddenly I blanked out there. And they have monitoring of the design. So they stated there, but it's not listed in 9.1.2, and so we need to add that in. Okay, summary of results of measurements at specified stages during the design and development of products and processes. And what do we have next? I thought we'd first bring in the sanction interpretation that we had the FAQ on. And that's all it says. Cyber attacks on information technology systems was added into the contingency plan. And they said the rationale was a possibility of a cyber attack that could disable the organization's manufacturing and logistics operation, including ransomware. And folks, if somebody went into a key supplier and did a ransomware, they could even threaten the OEM. Okay, hold them for ransom. And folks, this is real. This is happening to just about everybody around us. So we need to take it very seriously. And so here we have then in sanction interpretation number 17, it says, this is what we need to do. Every so often, we'll have to do cybersecurity testing, including a simulation of a cyber attack, regular monitoring of specific threats, identification of dependencies, prioritization of vulnerabilities, and it has to be appropriate to the risk. And folks, along with this testing, you need to be thinking about mitigation, which I'll talk to you about. And the rationale is, again, the idea that cybersecurity is a growing risk to the world, especially the US, and I think it's not, you've seen the NIST standards, and later on, if I have a webinar coming up just on this topic, you will see, and I'll quote to you a little bit later, even the SEC has told your board what they need to do. Let me tell you about that so you can go and talk to your top management that this is indeed, and they got to understand they shouldn't be doing separate programs for all of this. All of this is part of the same. NIST, of course, requires it if you're going to supply the government. And so you need to update your contingency plan, and you'll have to show that you're doing cybersecurity testing. This is not some sort of a trivial testing, folks. I'm going to have Anthony John talk to you about that shortly. But let me first cover the sanction interpretation and a little bit more in terms of what is called CIA, okay, of the ISO 27001 information security requirements. So, shall we just look at the assets of the overall enterprise? Not enough. You have to look at cyber protection of equipment and systems supporting manufacturing. This is sort of industrial cybersecurity. And cybersecurity, it says, is not limited to the support functions and office areas using computers. Manufacturing uses computerized controls and equipment and would be at a risk to cyber attack. So this is very, very essential. I don't know if you're aware of how using a USB, the US government put in a worm into the centrifuge systems of the uranium centrifuges for Iran and just made it run so fast it disintegrated. And that's the kind of things that can happen very innocently. If you are compromised, you know, there's much that can happen. This picture actually was taken from our ISO 27001 class and standard, that it says when you're doing the risk assessment, when you identify risks, you need to look at the loss of confidentiality, integrity, and availability, the CIA of information security. Information security includes cybersecurity, which is from the external, and it also looks at internal risk, and that's why information security looks at both internal risk and external risk, which is cyber security, external. Okay. Then this identification of risk is not a room full of people doing brainstorming. It is the use of tools, sophisticated tools that identify all the vulnerabilities of your system. And then you have to analyze the risk. Once you identify the risks, now we can use a risk treatment, analyze the risk, and then evaluate the risk, and then come up with the risk treatment. Oh, here's where, before I go on to risk treatment, let me tell you what you need to do to identify the risks. Anthony, would you like to talk about the next 3 slides, the 3 types of testing somebody needs to do?
Yes. Can you hear me okay?
Yes, absolutely.
Okay, perfect. Thank you, Chad. So, you mentioned this earlier. There are 3 levels of 3 types of security. One is the enterprise IT security. That's what we have the slide here. And there's also an IoT security. That's more and more enterprises are looking at IoT implementation within the company. And the last one is the industrial IT security. So enterprise IT security, is very established now over the last 2 decades. It started when Gartner came up with incorporating security in the enterprise architecture process. It was started as a silo approach, and now many of the companies have fully integrated that within the enterprise. Enterprise IT security is a methodology that ensures all the. Can you stay back? Can you go back? Yeah. Information security, process security, and also personal security is enabled. If you look at enterprise security, you are going to be looking at preventing, detecting misuse of information. More importantly, even defining the process with and letting people know what is the consequence of a misuse. Having physical security policy for an insider attack is very, very essential.
Most of the enterprise IT security attacks today happens through an insider. I think many of you have heard about the red dot, where two janitors just combed information available just from the office trash, and they were able to take credit card and fraudulent information, and then that was a very big attack. Physical security is informed, very, very important. Having maybe a two-factor or a multi-factor security would be very helpful. Training employees, I mean, most of the times, innocent employees are the ones who get, these phishing emails or some Trojan emails, and they end up opening those, so training your employees on the do's and don'ts. Today, the industry has changed a lot, where mobile is becoming an important parcel of your everyday work style. So people are bringing in their own devices to work. Sometimes your personal mobile is connected to the office network. So all these, where you might be using your personal mobile in a public Wi-Fi, Starbucks, or could be in an airport. So you could get compromised, and you can bring that information, those Trojans into your office network. So deploying antivirus, firewalls, anti-spywares, and having secure passwords, that's very, very essential. Again, more and more organizations today are promoting the idea of multi-factor authentication. It's more one password and another one, like a fingerprint or an access card or something like that. And then conducting a vulnerability assessment, penetration testing at a minimum, both for your on-premise and also a lot of cloud solutions that we have today is critical. Okay, can you go to the next slide, please? The next security is IoT. I mean, this is the buzzword. Everybody is implementing IoT. You see that footnote, 67% has experienced security issues because of unmanaged IoT issues. This is a publication from Forrester in September 2019. There are growing problems with IoT. IoT itself does not have a lot of security layers, meaning the transport layer of IoT does not support encryption model. So there is no HTTPS or authentications that's built in. So it poses a lot of challenge with IoT security. So one of the important things, a few of the things that we have noted here for IoT security would be, automating your inventory, making sure that you know all the sensors, routers, gateway, where they are, making sure you're segmenting your IoT devices in terms of prioritization and risk profiles. So what are your key sensors? Would you want to give the same sensor for a motion sensor to turn on lights versus a sensor that's controlling your process information network? So their prioritization and segmentation is important. Conducting an IoT security assessment, again, at a minimum of having to do some of these assessments is critical. There are more comprehensive testing tools available. So all these testing will require not just having to be at your facility or offsite. We also be using a lot of the tools to do the security. Patch deployment on IoT is one of those biggest challenges today. Most of the times these patches are available from an external cloud server. So those cloud servers are not secure enough, and then malicious code could corrupt your firmware and software and your sensors, and that could corrupt how your sensors could behave. Authorization and authentication. I mean, I don't know how many of you have done this. Even in your home, where you have your home devices that you have got, maybe home network or Google Alexa devices. All these devices that you have, IoT devices today you have at home. How many times you change those passwords? How often do you change your Wi-Fi passwords? So in a traditional industrial IoT, because the way they are set up, where you place these sensors and routers in different places, most of the time the default password is just what is used. Okay. Again, the cloud interfaces and mobile interfaces are another important part of IoT security. So all of that has to be covered when you look at IoT security. Next slide, please.
We'll pick up a little speed here, Anthony. I just looked at the time
Sure.
myself.
Okay, so the last one is industrial security. This is not the same as your enterprise IT security. It's a security model where you're not just looking at PCs, but you're also looking at all those operational technology like equipments, your SCADA systems, your PLCs, your ICS systems. All those need to be secured. In this one, making sure your assets. You can only control what you see. You can't see what you control. Well, if you can see what you have, you cannot control them. So cataloging all these assets as part of the industrial security is very important. Mapping all your assets and communications and making that sure that unauthorized connections are not made to these assets are important. More and more, today there are some of the old equipment still don't have so much of connected equipments, but they do have ports like the USB pen drive. So making sure that the right personnel have access to that network is important. Continuously monitoring and of course doing security assessments in all these industrial, in all the OT infrastructure would be very helpful.
So Anthony, thank you very much. So I wanted to make sure, a lot of our audience typically is either from engineering or quality, and they may not understand the gravity and importance of what kind of testing they need to do. So 3 types of testing, as you said: industrial, IoT, and enterprise. Okay.
Correct.
And
all these security are important.
Yeah. And Anthony, there are companies who do this, and I think we're also. This is something also Omnex Systems is ready to do. And let me just say, it's not just enough to do the risk assessment, but you need to also, once you identify the risk, the idea is trying to look at the risk owner and then calculate the likelihood and impact, and then do the risk treatment that you need to do. Okay. So again, the idea of looking at overall information security, cybersecurity risk, and then coming up with a treatment plan, and then coming up with controls, just like we do in manufacturing. And of course, you can imagine Omnex uses something very similar to a control plan also for cybersecurity and information security. So this is a webinar that's coming up, and you can see here that so we teach a ISO 27001 certified lead auditor course, but also understanding internal and lead. And you can find out not just what IT security and cybersecurity is about, but also what are the types of controls there's 114, if I'm not mistaken, inside 27001. NIST has 252, that's the government. And then, what I did want to mention to you is also the SEC is requiring now our top management in terms of yearly they have to make statements, and they have to produce a book on the results, and that needs to include, now the standard says, the SEC says, needs to include cybersecurity. So I'm a little tight on time. I'm feeling a little rushed, so bear with me, folks. So let's go through this section fairly quickly, Mike. So we have the SCAFF changes, and I'll just do that, and I'll bring you in some of these slides, okay? It's an initial agreement between the supplier and Ford Motor Company, and basically it describes all the special characteristics. You all know what special characteristics are from IATF 16949. It needs to be linked to the DFMEA, even if it's a DFMEA from Ford Motor Company. All right? And then the whole idea is to be putting it into the control plan. So you can see here that the FEMA and control plan, needs to align with the DFMEA, and I especially want to share with you a little bit later some of the requirements coming from Ford, which are very actually laudatory. So here it is. You have to look at the DFMEA, and the DFMEA will have something called YC and YS. These are the critical characteristics from Ford, which includes inverted delta and significant characteristics. And I'll show you a flow chart in the next slide, how they treat them differently. And all of that needs to be translated from the DFMEA. So this is the thing. If you all know the DFMEA, you know the DFMEA has no product characteristics. So how do we link product characteristics in the DFMEA? I'll tell you what Ford says, and then I'll add something from Omnex viewpoint. And then you have to include these characteristics, we would say in the process flow, FEMA, and control plan, and then in the shop floor. Mike, any comments you want to make in terms of SCAF?
It's a very detailed process. It's in addition to some of the requirements that are already in APQP and PPAP to really nail down these special characteristics, especially the ones that have to do with functional safety, and understand how you're controlling them and tracking them all the way down through your supply chain.
Okay, and just something here, and I really like this. You can see where the product characteristic comes in. And folks, I want to brag a little bit. I don't know how long ago, but 3 or 4, I don't know how many years ago, Omnex started teaching it, and we actually all have it already incorporated into our software, linking product characteristics to the cause. But you also have to have one other link, which is functions have requirements, requirements have characteristics. So we do and we teach linkages in both places. Mike, any comments on this?
Not really. Again, it's trying to tie the both the DFMEA to PFMEA and lock that down. So it depends on whether the supplier has control over the design or not. If they do, then they're going to have to show this linkage between their own DFMEA to PFMEA.
So here's the deal, Mike. DFMEAs don't have product characteristics. You have to do this. Nor does PFMEA. PFMEA doesn't have characteristics unless you do something. So what does a supplier need to do in the PFMEA to be able to see product characteristics?
Yes.
Yeah, okay. So this is what we'll have to do. For number one, you have to recognize that the failure mode is a failure mode of characteristics. So actually, this is something we taught, Mike, since I don't know, since maybe mid-90s. We opened up a column called characteristics column in the PFMEA, and we linked failure modes to the characteristics. So it really prevents what we call column switching, where people put a cause in the failure mode. So you actually have been teaching it like that. That's probably why you didn't quite recognize it. So, but in most PFMEAs, the characteristics column is not open. So you'll have to create a PFMEA format. And I think you guys put that into the 4th edition. Am I right? Since Greg is also part of the team, I imagine that's something the 4th edition has as one of the formats. Yep. Folks, I apologize, we're running a little late. Let me just go on to this. I wanted to have a nice discussion with Mike on this, but I might just skip that. But I want you to know, suddenly occurrence comes in. And on the manufacturing side, if you have occurrence greater than 3, not 3, but greater than 3, you need to call it a significant characteristic. I'll also say one thing, Ford dictates pretty much controls for a CC, less for a SC, but you have to put in the appropriate controls. Mike, if I suddenly asked you, What is sort of the occurrence numbers for more than 3? What would that be? And I'll just
Well, in the old system, it's 1 out of 10,000. In the new system,
1 out of 10,000. Okay.
yeah, in the new system, it's more vague. It's just basically saying you have a really good control system.
Okay. So one of the things we have done is created a Ford-specific courses for our customers. Folks, thank you for staying with us a little over. I'm going to stay. You probably have been sort of a little bit trained by us that we run a little over. This one I actually thought I would get finished much earlier. So here's the summary, and then I'll take a handful, at least 5 questions. And Anthony, there'll be some for you, Mike.
Okay.
So AIG VDA FMEA is becoming an alternative approach and will become mandatory in the future. So AIG VDA FMEA training and pilots we think should be planned today. Also, especially if you're in the EV, AV, or functional safety or cybersecurity, we think you should have started that a while ago. You know, the engineering V and the model, the flow down and the testing flow up. It's the key reason why we're saying if you're doing functional safety, ASPICE, or cybersecurity, you should do it. Next, implementation of TPM, cybersecurity, enterprise, IoT, and manufacturing testing needs to occur on a regular basis. And we are encouraging folks not to use an ad hoc approach, but to use a management systems approach. Implement ISO 27001, which is a management systems that follows something called a high-level structure. And then SCAF and Ford approach to DFMEA, PFMEA, APQP, PPAP is necessary for Ford suppliers. So a little bit on our upcoming webinars. You can see we have really good different webinars for free webinars. And of course, some of the training books I've written actually, and then some of the training we have at Omnex. All right, with that, let me do this. Let's go and answer some of the questions we have. Okay, I'm going to give this to you, Mike. Please explain a little bit more about updating process of FMEAs. Okay, process of FMEAs. It's a little bit because it's Spanish. Actions recommended M and H status. So I don't know if you can make out the question. If not, I'll go to a different one.
I'm not sure what he's asking.
Yeah. Let me just go on here. Pick one for. I think this was answered, Joseph. I'll have Anthony just say, what about IoT devices and smart IoT? He says.
I thought that's the IOT security, maybe that was another
Exactly.
slide.
I think this may have been an early question before we talked about the IoT also testing.
Yeah.
And we have a question from Mary. If not design responsible, what is the recommended linkage if I'm not provided the DFMEA by the customer? That's a tough, yeah. Age-old problem in the automotive industry.
Yeah, and basically, they're required for the functional safety part. So if you're working with functional safety, you may not get the DFMEA, but you'll get the lines of the DFMEA that are critical to the supplier. But that's an age-old issue.
So, Mike, we can say for Ford with the SCAF, now you will get the DFMEA. And it's something really top management is looking at.
That's right.
For the other OEMs, you know, I know because we're talking to one of the other OEMs, I know they're fairly serious about these linkages, especially if you're going to do AIG, VDA, FMEA. You cannot do it if you don't have that customer linkage. Okay, is that fair to say?
Yeah, it actually puts your OEM on a liability issue, not providing that information. So I would assume that that's going to be something that they're going to always do in the future.
So,
but if I'm doing my PFMEA and I don't have product information, I would highlight those lines and have that discussion with the OEM when they come to visit. That you're not getting that information, so you can't really do a good evaluation of risk unless they're telling you where the critical characteristics are.
okay. So one more question for us on the AIG VDA FMEA. You know, and regarding the mandated requirements of AIG VDA FMEA format, is saying is for direct OEM suppliers, giving tier ones the authority to push into sub-tier supply base. I think that power was always there, but in fact, because AIG VDA is being required, you know, it surely does give added impetus and added momentum to the tier one to require the supply base to, identify how they are treating the failure causes, as they call it, at the lower level. Comment, Mike?
Yeah, the suppliers don't want to take on that liability. If it's not clear to them what the system effect is of a failure, they need to get that information and not assume it, because then they're assuming the liability.
So, thank you very much. Folks, I hope this was a good webinar for you, full of information. And thank you for attending this webinar and hope to see you in future webinars. I'd like to thank my, co-presenters, Mike Down, Mr. FMEA, I'll say Mr. Core Tools, and Anthony John, who is very proficient and leads our software company, Omnex Systems. Folks, thank you very much. Thank you all for attending. Take care, everyone. Bye-bye.
Bye.
Bye, everyone.